Okay, and so today on functions, we are going to investigate if a function is injective, surjective, and if they're both of those, then they would be bijective functions. Okay, and so before we look at whether they're injective, surjective, or bijective, let's just remind ourselves of some of the terminology. So here we have a function machine, and we could call that machine, this time we'll call it f. So if our inputs here are x, then our outputs are f of x. So f of x. Okay, so now we know our input. The other word for that is our domain. And we know our outputs form the range. But our outputs, the range, is part of a set called the codomain. So here we have our range as part of the codomain. Okay. Here in this diagram here, we have our domain. We have our codomain here. And in between, we have our function, the rule that happens to whatever elements here in our domain, for example, x, that sends them, once they've gone through the function, that it maybe sends them over here into the codomain with an image or a different value. Okay, so first our definition of injective functions. So here we can see an example of an injective function, and that means basically that every element here in A, in our domain, is mapped onto a distinct element in B, our codomain. So no two elements here go to the same output in B. Okay, so our definition here. So really important that we note down the word distinct. So they have to go to distinct elements in our codomain. Okay, and so another word for injection or one-to-one or injective functions is that they are one-to-one functions. Okay, so each element has its own distinct output, each input. So if I want, I can see from this diagram here that everyone had their own distinct output. If I want something to be not injective, say for example, if I had this function here and I had another element in A, well, if I have that mapped on here, that's clearly not injective, because now I have two things going to the same output. So this example now is no longer an injective function. We know it's still a function because every input has a unique, has an output. It's only going to one output. However, it's not injective because it's no longer one-to-one. They don't have a distinct element here that they go to, because we have these two elements going to the same output. Okay, we'll take a look now at surjective functions. Okay, so this diagram here is an example of a surjective function. So we can see here there's two elements in set B, and both of those elements have been mapped to from set A. So there is an example of a surjective function. If I had, for example, here another element in B, then it would no longer be surjective, because we now have this extra element here in B that doesn't have anything mapped onto it. So that would no longer be surjective. Okay, so here we have our definition then of a surjective function. So every element in B then is mapped to it from the domain A. So in essence, we could say here in B, or in surjective functions, our codomain is equal to the range or to the image. And so also another term, because it's mapped onto every element in B has been mapped onto it from A, surjective functions are also often known as onto functions. okay? And then obviously we said earlier that an element is not a surjective, or a function is not a surjective function if, for example, we had, so that's our example of our surjective one, and down here our example of our non-surjective one is here having an extra element in B that hasn't been mapped to it from A. So this is not surjective, this function down here. Okay, so very simply then, bijective functions are both surjective and injective. That means it is both one-to-one and onto. Okay, so that's our definition there. And let's look at an example of one that is both one-to-one and onto. So this is both because every element here in A is mapped onto a different element here in B. And so that's the injective part. And the onto, the surjective part, is that all of these elements here in B come from A. There's no extra elements. Okay, so that's injective, surjective, and bijective functions. They're the definitions and how we explain them. And so just looking at them further, so if we want graphically to see whether something is injective or surjective, we can use a horizontal line test. So first of all, in relation to its injectiveness, if I draw a horizontal line across here, it just hits the function, hits the graph at just 1 point, just right here, which means that's one-to-one, it's injective, okay? Similarly, I can see in this one, so all linear graphs we would imagine are going to be injective. If I draw the line y equal to 2 here, I can see that it hits this function at just 1 point, so that's also injective. If, for example, though, I have a function here and a quadratic function, so I have x minus 1 all to be squared, well then, if I draw the line y equal to 3 across here, that hits the graph here, and it hits the graph here, the function here. So therefore, this one is not injective, okay? So for something we've said about injective is often known as one-to-one. It can only cross, the horizontal line can only touch the graph or the function in one spot. So here and here. We can also use the horizontal line test for surjectivity. So I know if something, for example, to be injective, can only touch the line or touch the graph, the function at 1 point. Whereas for something to be surjective, it has to touch it at least 1 point. But we know that every element in the codomain of the outputs has to be used. So say, for example, if we were told in this graph here that the y value, the codomain, could be an element of the real numbers, which means it could also include negative numbers and fractions on the negative side. We can see this graph, if I draw a line across here at minus 0.6, it is not going to touch anything. So that line would be not surjective, or so that function wouldn't be surjective because it has, if the range, for example, the codomain is wider. However, if we were told that the range, the codomain, is only where x is, or the codomain is y equal to f of x, such that x is an element of R, is fine, and x is greater than or equal to 0. Well then, when I am drawing my line across here, it hits it no matter where I go at least 1 point, so then it would be surjective. So we'll take another look at surjectivity with another graph. Okay, and so in this example here, we are asked to consider this function, so a sine function. So we know its period is 2 pi, and we can see that its range is -1 to 1. And we're told this in the function here, that the range is -1 to 1. And so we're asked, use the horizontal line test for surjectivity to determine whether the given function is surjective or not. So here they've specified that the range can only be from -1 to +1. Well, we know it from trigonometry that our sine curve only goes between those values. So no matter where I draw my horizontal line along this graph, I can see that function between -1 and 1. That function is going to hit the graph in at least one place, and sometimes it will be in 4 places, okay, or more. So yes, this is surjective along here. If, however, they didn't include this range, they just said test the sine graph, and they didn't have it limited to between -1 and 1, and I was to draw a line up along here, for example, well then I would know that it wasn't surjective. So here they've limited the range, they've limited the codomain to between -1 and 1, and so then I can see or can say safely that it is a surjective function. Also, just before we finish up here, as we know with quadratic and cubic and trigonometric functions, that we have, they are not injective, then we know also they can't be bijective. So here, where we have linear functions that are injective, we can see, are they going to be bijective as well? So therefore they could be, are they going to be surjective as well, and therefore bijective? We can also investigate exponential graphs can be injective. So quadratic and cubic and trigonometric ones that are shaped like this, where we have a nice period, they won't be injective, but it's not to say that only linear functions are, because exponential ones could also be injective and surjective and therefore bijective as well. Okay, so let's make sure to get all those notes into your copy, and we'll do some questions as a learning check.